Good afternoon, my YouTube viewers. It is Crystal here, and I'm here to give you a code review. And this code review is going to show you how to vectorize tweets and with TensorFlow. And I've got lots of code from all different places to try to make this program. And originally, I sort of got the code for sentiment analysis from using an inbuilt TensorFlow dataset. But the thing is I thought, well, you're not going to be using inbuilt TensorFlow datasets all the time, so you're going to have to find another dataset to use. So basically, I sort of like swapped around this code that I found from all these different places to try to make it where I could use a CSV file and not a TensorFlow inbuilt dataset. And the reason for that is so you can use any dataset that's got text in it and use it. So that's what I wanted to do. So I wrote this program in Google Colab, which is Google's free online Jupyter notebook. And Google Colab is a very good platform to use, with the exception of the fact that it doesn't have a very good undo function. So you need to be very careful that you don't sorry, just a second. Let me finish this. Do something. Okay, I did it. So that was good. I was making another video before I made this video, and I was a little bit worried about it. So now I can carry on with this video. But you need to be careful not to accidentally overwrite or delete any code, because if you do overwrite or delete code, you might not get it back. So that's one thing that you have to be very careful for. So the first thing that we're going to do is we're going to import our libraries. So you're going to import NumPy as NP, which is for your numerical computations. We're going to import Pandas as PD, which is for your data processing. We're going to import matplotlib.pyplot as PLT, which is your graphical visualization. We're going to import datetime because somewhere in the program they ask for a datetime, but I'm not really going to use it. So if you don't want to import it, you don't need to. We're going to import re, which is an inbuilt library with Python. And we're going to import string, which I think is also an inbuilt library with Python. And so re is for string processing, and string is for string processing as well. And then we're going to import all of our TensorFlow libraries, TensorFlow as TF, and then we're going to import all this other stuff with TensorFlow as well. And you want to see what version of TensorFlow you're using, and it is 2.11. So you need to know what version of TensorFlow you're using. And the reason why is because TensorFlow goes through so many changes. And so, in my opinion, it's more difficult to program in TensorFlow, because especially if you're not really sure what you're doing, because the library has gone through so many changes. And so that's one of the reasons why it takes me so long to actually program in TensorFlow. But maybe when TensorFlow settles down and they stop making so many changes, then maybe it'll be easier to program in TensorFlow. But I do find programming in TensorFlow much easier than programming in PyTorch, because I studied a little bit of PyTorch and it was very difficult for me to do so. But maybe it's because I've learned a little bit more about deep learning and not so much PyTorch, but I'm going to try to stick with TensorFlow as long as I can. So after we have imported the libraries, then what we need to do is we need to load the CSV file that we're going to use. So what I had been working with originally was I had been working with TensorFlow inbuilt datasets, and I just thought to myself, well, you're not going to be able to use a TensorFlow inbuilt dataset all the time. You're going to need to have a CSV file. So I found this CSV file on Twitter Analysis, and that's what I'm using. So we're going to use pandas to read the CSV file. So df equals pd.read CSV, and then you get the CSV file, the web address for the CSV file, and then it says df equals df.drop id axis equals 1 because it had an extra column in it called id, which you don't need that column. And the reason why you don't need that column is because with pandas, every row is indexed anyway. So we just got rid of that column because we don't need it in pandas. Now you can see that because they're tweets, they've got hash marks and @ signs. So that's something we need to be aware of. So now we're going to analyze the data frame. And I suppose what I could have done, let's just do this. We're going to import Seaborn, and which I should have done this, but I didn't. But we'll do it now. And KDE stands for Kernel Density Estimator. But what I should have done it, I noticed that whenever I was going through the libraries, I noticed that I hadn't imported Seaborn, and because I hadn't imported Seaborn, I didn't have the graphics that I wanted. But we'll go ahead and put the graphics now. So here's your graphics, and so basically what you have is most of them are 0, and you have just a few of them are 1s. So that's it, sentiment analysis. So most are 0s, and a few of them are 1. And then so what we do is we do a value counts. So we see that 0 is 29,720 and 1 is 2,242. We see that there's 2 classes. And now what we're going to do is we're going to split the data set up. So X equals DF tweet, Y equals DF label. And then we're going to use sklearn train test split. So x train xval, y train yval equals train test split xy. Test size equals 0.1. Random state equals 42. Shuffle equals yes. And then we check the shapes of all these. So we've got the shapes of x train, xval, y train, and yval. And now what we're going to do is we're going to take x train, xval, y train, and yval, and we're going to convert them to tensors. So it's going to be x train ds, xval ds, y train ds, and yval ds. And now what we're going to do is vectorize, and this is going to be a little bit different from the sklearn stuff that I had been doing, but we're going to do a custom standardization where it accepts the input data. So lowercase equals tf.strings.lower input data. Stripped HTML equals tf.strings.regex replace lowercase, and then it's going to replace the the break with a space. And then it says return tf.strings.reject replace stripped HTML, and these are just some codes that I said to strip it with, like a percentage point, an S, a hash mark, and an @ sign. And then it says percentage point re.escape string.punctuation, and then it's going to replace it with a space. And then what we do is we're going to say max features is 10,000, sequence length is 250, and now we're going to use text vectorization with TensorFlow with text vectorizer equals layers.text vectorization, standardize equals custom standardization, max tokens equals max features, output mode equals int, output sequence length equals sequence length. And then now what we're going to do is we're going to make a text data set without labels, then call adapt. So features equals xtrain ds, text vectorizer dot adapt feature. So you have to use adapt with this. And then def preprocess is return text vectorizer. And so here's your text vectorizer here. And that's your function, return text vectorizer. So now what we're going to do is we're going to define our model. Keras input shape equals 1, comma, dtype equals string. Outputs equals layers.dense1, and then it says pre-processing inputs. So pre-process input. So you've got your function pre-process, and it returns text vectorizer, and it returns your inputs. And then model equals keras.model inputs, comma, outputs. And then what we do is we compile our model, and so optimizer is atom, loss equals binary cross entropy, from logits equals true, metrics equals accuracy, and model equals summary. So this is your model. So you've got your input layer is 0, your text vectorization tokenization is 0, and dense is 251. And then so what they've done is they plotted the model. You can see input layer, text vectorization, and dense. And then they plotted the model again, so you can see it again. And then it says we're going to create the TensorBoard folders. So it's going to create a TensorBoard, but I'm not that worried about that. But well, you do need it because it says log dir equals fits logs fit datetime.datetime now's drift time, and it says create callbacks. So my callbacks equals keras.callbacks TensorBoard log dir equals log dir keras callbacks dot early stopping monitor val loss and patience equals 3. So now we're going to fit the model, which means we're training it. So epochs equals 40, history equals model.fit, xtrain ds, ytrain ds, epochs equals epochs, validation data is xval ds, yval ds, callbacks equals my callbacks, and verbose equals 1. So it trains the model for 7 times, and when it trains the model 7 times, you get a val accuracy of almost 90%. The length of is the number of epochs, and that's number 7. And this is something that I couldn't get it to work. It says loss accuracy equals model.evaluate xval ds, and it says loss is 0 and accuracy is 0, and I couldn't get it to work, but I left the code in there anyway. So history dict equals history.history, history dict keys. So you can see that the dict keys are loss, accuracy, val loss, val accuracy. And then you've got your ACC equals history dict accuracy, val accuracy equals history dict val accuracy, loss equals history dict loss, val loss equals history dict val loss. Epochs is range 1 to len ACC plus 1, and then it makes a little graph that shows you the training loss and the validation loss, and make another little graph that gives you your training and your validation accuracy. So now we're going to do the probability model equals keras.sequential, and its model layers.activation is sigmoid, and ypred equals probability model dot predict xval. I tried to use xval ds and it wouldn't work. I had to use xval, and then you like check ypred, which is a probability. And then now what we do is ypred equals ypred is greater than 0.5.s type int 32. Ypred equals ypred flatten, and then there's your ypred, and most of them are zeros, and you get some ones. And then you get what thing that you can do is you can say, let's see if we can get it to work. Ypred value counts. No, it doesn't do that. But let's see if we can get this to work. Try that. So that worked, and again it tells you most of them are 0 and a few of them are 1s. And then, so it gives you an accuracy of 89%, which is almost 90%. We can also do something called a confusion matrix. Check out the confusion matrix, which I should have done, but I spent a lot of time working on this, and so when you spend a lot of time working on things, you get really tired. But we'll do the confusion matrix. We're using sklearn's confusion matrix, by the way. See if the confusion matrix works with it. So the confusion matrix works. You only had 10 number ones that were correct, but you still got a 90% accuracy. So there we go. There's our code review. And then you can also save the model if you want to use it again, because that's what it's all about. That's what TensorFlow is all about, is saving the model. So we save the model as tweet model. So if we come over here, it's got tweet model in there, so it's saved. And what you could do is, like, if you had some more data and you wanted to use some more data, you could input some more data in there and get it to work, because that's what it's all about, because they want you to call up the model again and reuse the model on other data, which I haven't done it in this particular one, but I'll see if I can find one. This one, sentiment analysis. It's just taking a little while for it to load up. So we'll come over here to the end of the program. So we had, so let me find out where we saved the model. And you see that it worked here. I'll show you where it worked. It worked here, but it didn't work on the other one. It says test.batch 512, but it didn't work on the other one. Probably because I didn't put batch.512 in there. We'll try that again. So you've got your tense boards. It says no dashboards are active for the current data set. So you didn't really even need the tensor board. But here are some examples. And then here's your model. And then prediction 1. And then it says we save the model. And then we do everything that we did previously. But I think that prediction 1 is 100. So that's going to be, the movie was great, that's 1. The movie was okay, that's 0. The movie was terrible, that's 0. So in theory, you should just be able to put some text in there, and the model should be able to work on it and make predictions on it, which is what they want to do. But what I'm going to do is I'm going to come over here and see what happens. Let's just see what happens when I say let's see what happens. No, it says invalid syntax. Let's try it again. It says tuple object doesn't say batch. So let's try it again. So we couldn't get it to work. It says verbose equals 2. It says let's try it once more. It won't work. See. So it doesn't even give you a batch. And it says that it doesn't recognize the batch. See what happens. Nope. It just goes into error. So it said it expect 1 input. but it received 2. Nope, it doesn't recognize batch. So it just doesn't work. So I did my best, everything I could think of, to try to get it to work, and I couldn't get it to work. So I guess that's it for the code review. I've talked for 25 minutes. I hope you like the code review. I'm going to go ahead and do this on a Kaggle competition and see how far I get, see what my output is. So thank you so much for watching my video and helping me to do troubleshooting. And if you like my video, please like, subscribe, and share. And thank you to my subscribers for supporting me. Thank you for watching my video. I look forward to making more code reviews for you in the future.